Okay, how are you everybody who is watching this video across the world? I'm very happy to have you today, and I would like to take this opportunity to welcome all the physical engineering students that I have in this class, and also the online student. My name is Olenjolai. If it's the first time to meet me, I'm very happy to have this opportunity to train you and to teach you about electronics. I have some physical students that I've said, and my classes will be very interactive, and to the course that I'm going to teach you, the modules that I'm going to teach you, we are going to enjoy about the theories of the digital electronics. It's called digital electronics. We are going to enjoy the simulations of the digital electronic system, and we are going to enjoy the practical of digital electronic system. So I'm very glad and I'm very happy, and I thank God because I believe that He has prepared to feed your mind. The philosophy that I have in the world of engineering, it's mind and the hand. Engineering is all about your mind and your hands to do something. So, if that's the case, I don't want to waste much of your time. We have a module called Digital Electronics. We are teaching our physical students at Dar es Salaam Institute of Technology in the beautiful country that called it Tanzania. We can welcome you to join because digital electronics, it's a universal subject. And electronics engineering is a universal subject. We are in chapter 1. This is our first chapter that called the combinational logic circuit. And this is lecture 0 because in digital, 0 has a meaning. In case of the marks and whatever, if you score 0, you know that actually you have failed, yeah? But in digital, if you have 0 bits, that's a very wonderful information signal that we can use to activate something in digital system. So, if that's the case, I want also to mention the contents that I'm going to teach you in this module will help students who are actual pursuing ordinary diploma in the 6 related fields of engineering. Or it will help students who are beginner and intermediate pursuing bachelor degree in electronics or in 6 fields that I'm going to mention. So these contents are specifically prepared and dedicated, and I'd like to dedicate to all students who are pursuing electronics engineering, to all students who are pursuing telecommunication engineering, to all students who are pursuing biomedical engineering, to all students who are pursuing mechatronics engineering, to all students who are pursuing mechanical engineering, to all students who are pursuing computer engineering, to all students who are pursuing electrical engineering. So I have mentioned these 7 fields related with electronics engineering. And today I will introduce to you why those related fields such as mechanical and mechatronics engineering study or are supposed to study digital electronics. We don't ask them to study, we don't ask you to study because you want to add the modules. No, it has a great contribution in most of the modern mechanical system. So if that's the case, this is interactive course. In case you have a question, ask it. Now, let me appreciate the presence of the physical students, then we'll go to lecture 0. How are you, students? How are you, students? Now, how are you, student? Okay, do you like mechanical engineering that we are studying? Yes. Good. Let us go to the business. So, the module or the course is called Digital Electronics. Say Digital Electronics. Digital Electronics. All the students, physical and online, say Digital Electronics. Digital Electronics. So if we are singing songs, this will be our chorus for this song. We are singing a song that the name of the song is called the Digital Electronics. And in this semester, actually the chorus of the song will be called the Combinational Logic Circuit. Say Combinational Logic Circuit. Again, students, say combinational logic circuits. Say combinational logic circuits. So before, and then this is lecture 0. We'll have lecture 0, lecture 1, lecture 2, lecture 3, lecture 4, lecture 5. Up to, I don't think that if we have an end, maybe we said, okay, let us end there for this semester. Right? For me, I like digital electronics. How about you? Do you like it? Ask your neighbor, do you like it? Okay. So, before we dive into the digital electronics concept, let me give you just the general introduction. The general introduction. Let me build your mindset. The general introduction of engineering concept. Engineering concepts. So, the first philosophy that, or the first engineering concept that I would like to build it to you at the beginner in this field is called the engineering. And then we have a very fundamental question 1, which is I would like to ask you as a student, what is engineering? You are studying a course in either of the 7 fields of engineering. But let me just ask you a question. What is engineering? How can you define engineering? Who can try? What is engineering? For the students who are physically here, they are pursuing mechanical engineering. So what is engineering? Before we define about what is mechanical engineering, before we define about what is electronics engineering, what is engineering? Because remember that when we've been admitted in Form 1 education, we've been told that science can be broken down into 3 subjects: physics, chemistry, biology. And then the first question that we met in learning physics or chemistry or in learning biology, definition of the subject. What is physics? What is chemistry? What is biology? And even if you don't understand, because by that time you are from Swahili primary education, but you have to claim, you reinforce the understanding. Physics is a branch of science. Then we had a common conjunction, which deals with. Chemistry is a branch of science, which deals with. Biology is a branch of science, which deals with. So before we talked to you about maybe equilibrium, chemical equilibriums or chemical kinetics in chemistry, or before we talked to you about mechanics, before we talked to you about motion, before we talked to you about force, about different types of the energies, we defined the subjective first. Right? So possibly up to this time, you have never asked yourself about engineering. But let me ask you a very interesting question. What is engineering? Then spend a few seconds to tell your neighbor what is the meaning of engineering according to what you understand. Quickly. Tell your neighbor. So tell what you are thinking. And the neighbor, listen, careful. Communicate with your neighbor. Some of the students here, they don't like their neighbors. Okay. So engineering, in addition to the definition of your neighbor, engineering is the purposeful use of science. This is the simple definitions of engineering. Engineering is the purposeful use of science. This is one of the definitions. You may use also other terminologies to define. Class, let us read. Say, engineering is the purposeful use of science. Engineering is the purposeful use of science. Well, then number 2, we have mechanical engineering. I will bring you to digital electronics. You should not worry. I will bring you to digital electronics. You should not worry, but let me build something in your mind. We have mechanical engineering. Then we have very interesting question 2. What is mechanical engineering? What do you understand about mechanical engineering? Mechanical engineering. So while you are writing that question, that what is mechanical engineering, let me just remind you. According to the curriculum of United Republic of Tanzania, since the primary education, we've been taught science since standard 3. Isn't it? We've been taught science since standard 3 up to standard 7. Once we joined the Form 1 up to Form 6, we have been learning about physics, chemistry, and what? Biology. Why did we learn science in primary education, and why did we learn science in O-level education and A-level education? This is the answer. For you, you want to learn about engineering, right? You cannot understand engineering if you don't understand science. So the prerequisite of engineering is understanding of science. Are we together? I have some physical students who are we together? Yes. You should love like this stuff and should be more energetic because you are still a teenager. So it means that if you don't know science, you will not understand engineering. If you forgot the science we taught in primary education and secondary education, forget to understand practical engineering. Simple. That's the simple philosophy want to tell you the truth. Okay? And that's why we taught you science for 11 years. Standard 3, Standard 4, Standard 5, Standard 6, Standard 7. How many years? 5 years. Form 1, Form 2, Form 3, Form 4, Form 5, Form 6. How many years? 60 plus 5? So for 11 years, we have been preparing you to study about what? Engineering. So don't tell us that engineering is a new terminology in our mind. It's according to what you have been looking for. If you have been looking for the maxi, yes. So you're a political engineer. Because also you are political engineers, especially in our country, Tanzania. Are we together? Then, but also, when you say that there is no any means you can learn science without mathematics. That's why we taught you mathematics for 13 years. We used to teach mathematics from kindergarten. 1, 2, 3, up to 10. That is mathematics. And that's called decimal number. Okay? Okay? So, simply, we say engineering, you need a pure knowledge of science and pure knowledge of mathematics. That's why we've been teaching you about those subjects. Are we together? Now we come for the mechanical engineering. There's a different ways that you can define mechanical engineering. But this one, it's the one that I prefer. Mechanical engineering. Can you ask your neighbor about the definition of mechanical engineering? Now, your neighbor can tell you some information. Because he or she has already a key there. That is science. Okay, so you just add something there. So mechanical engineering, we say that is the purposeful what? Use of what? Mechanical what? Science. Simple like that. You will never forget this definition. So you are learning mechanical engineering. If you forgot mechanical science, then expect it to be a political mechanical engineer. You know the political mechanical engineer, not practical mechanical engineer. You will be speaking a lot of concepts of mechanical verbally. When we give you the stuff and build it by using your hands, then your hands can't work. But just to explain, so in this system, this is the gear. So when this gear functions, it activates the engine. And if the engine function activates whatever, the back wheels or the forward wheel. But theoretically, now we have the gear, we have the engine, we have connected them. Then we say, I haven't been taught at college. Are we together? And then not this point, we say that mechanical engineering is the mother of all other engineering what? Fields. It's a classical engineering fields, but it's a mother. Say mother. How many students would like to be mothers? Future mothers? Are you there? Mothers, are you there? Uh-huh. So you know the responsibility of the mother in the family. That is one point. Then, if mechanical engineering is the mother of all other engineering fields, including electronics. For example, myself, by God's grace, I'm an electronics and telecommunication engineer, so I am your child. So you are my mother. So when I meet with you, I have to speak with respect that I'm teaching my mothers. When we say that mothers, we don't mean it's about male and female. Does mechanical engineering has a gender? No. So we just call this mother. It means that this is the first field, engineering fields, and other fields have been built or have been born through this one. Are we together? Yes. But we have digital electronics. Let us focus. Then I have to build the electronics engineering. I have to build these concepts also in your mind before I take you to the combinational logic circuit. Say electronics engineering. Say electronics engineering. Okay, this is question number 3. What is electronics engineering? So now I have opened your eyes. So you know how to define electronics engineering, isn't it? In Bongoland, once you give them the key, then they continue. They get in themselves. They open the door and get in themselves. So you know, how do you define? You don't want to bother your mind. Electronics engineering is what? Purposive use of what? Electronics what? That's all. So you came to learn how to use purposefully mechanical science. If you don't want to use mechanical science, leave. You are wasting your time. So electronics engineering is the purposeful use of electronics science. So in order to understand electronics engineering, because digital electronics is the one of the field or it's one of the branch of electronics engineering, you have to understand what electronics science. Say electronic science. Say electronic science. And then we've been introducing the concepts of electronics at the one of the topic in physics form 4. The first one, one of the topics is called we call them the vacuum tubes, something like that. And then the next topic, I think the first topic in physics form 4 is called electronics. We've introduced it there. We've introduced about the diode. We introduced about the transistor. That's electronic science. But then when we have gone for A level, say A level, we had a very interesting, it's one topic, but it looks like it's some number of modules in case of college level. That's called advanced electronics science. Right? According to the curriculum, according to the syllabus of United Republic of Tanzania, the electronic science that we are training our students, it has been divided into 5 parts. Right? The first one, we call it semiconductor. Say semiconductor. Where we talked about intrinsic semiconductor, extrinsic semiconductor, valency bandy, conduction bandy, forbidden energy gap. We talked about those information. That's all about what? Semiconductor. Are we together? Are we together? Then we talked about the p-n junction, the potential barrier, and a lot of the information about that's the electronic science. Then the second field is called the transistor. Say transistor. Transistor, we call it the steady generations of the computers. Once the transistor had been discovered in 1950s, then it changed the world of computer. So if you talk about the generations of the computer, the third generation was what? Transistors. The use of what? Not the second generation. Because the first one, it was the use of vacuum tubes, where you find that the computer is huge, like this class, one computer. Can you get it as a laptop? No, you can't. But once there's the inventions of transistors, bipolar junction transistor and field effect transistor, then we have portable computers and very powerful computers. Are we together? Are we together? Then the next branch of what? The next branch of science that we taught you, the third one, is called the operational amplifiers. Say operational amplifiers. We talk about op-amps, non-inverting op-amp, inverting operational amplifier. Then we had and then we learned almost about 7 applications of op-amp. The first one, an op-amp can be used to design a differentiator. Op-amp can be used to design an integrator. Op-amp can be used to design a stable multivibrator. Op-amp can be used to design a multi-stable multivibrator. Op-amp can be used to design monostable multivibrator. Op-amp can be used to design filters. So we learned them and we did a lot of calculations and draw some graphs and whatever. Right? Right? That's the third what? Branch of advanced electronics what? Science. Then the first one. Says the first one. Say the first one. It's called the digital electronics. Digital what? Where we taught you about what? Boolean laws. We taught you about what? Logic gates. We taught you about what? Boolean laws and how you can simplify them and how you can use them. And about designing and about solving real life problems. That's what we have taught you. Is it true? Is it true? Can you refer the notes of Mgote? Sam Gote? Yeah, if you forgot, just refer notes of Sir or physics teacher called Mgote, Saidi A. Mgote. He has been our ancient teacher. If you don't appreciate him, for me I appreciate, because I read his notes and helped me a lot to understand a lot of concepts. But because you have jealous, you'll never appreciate people who are doing good. And that's the problems we have in our country. To appreciate people. Are we together? Then the fifth one, because I told you we have 5 branches. Remember that this lecture, just to do the quick review of what you know. In case you forgot, you have to go and look them. Because we have to teach you how to use what you know in electronic science. Then the next branch is called the telecommunication. That's the next branch of what? Of advanced electronics science. Do you remember? We talked about what? Transmitter. We talked about what? Receiver. But possibly maybe most of you did not cover advanced electronic science. Why? Because the time was not on your side. And also stuff there are a little bit difficult. You read them the whole night. You don't understand. You read them and then after a short time you forgot. And then when you listen to the class teachers, most of them maybe they are not specialized in that. They explain the stuff, but you forgot on the blackboard. So, and then you say, okay, but how many marks will I earn in the physics paper 1 and physics paper 2? Because we used to learn some topics, especially when we are getting prepared for the national exam. We just measure how many marks can contribute. The topic which is difficult and contribute 10 marks. Oh, you tell it goodbye. And then you ask some of your friends, will I pass if I don't study electronic science? Yes, you will pass. So you run advanced electronic science there, but now we quote you. Say, teachers have quoted me. You cannot run digital electronics. But maybe you disliked it because of the way of teaching. Possibly. Right? Maybe. Because some the way of teaching can make students to dislike. But for myself, I will try my level best to convince you to love this field of science. Okay? Then, are we together, students? Yes. Number 4. Now, we have a name of our module. It's called what? Digital electronics. And then the simple question. What is digital electronics? What is digital electronics? Ask your neighbor now. What is digital electronics? Because you learned in A-level. Ask your neighbor. Love your neighbors. Love your neighbors. That's the second command. Love your neighbors. Because your neighbors are very important people. Maybe one of your neighbor might be a president of this country. So establish the relationship now. So even if later on he or she will be a prime minister of our country, then you can have an access, simple access. Hey, do you think that we expect you to have leaders fall from heaven? No. Did you ask your friends? So your friend now know the philosophy, eh? Just replacing some words in those prior definitions and then placing some of them, right? Wonderful. You are right. So digital Electronics, we say that, is a branch of electronics. Is a branch of electronics engineering which deals with the purposeful use of digital electronics science. So this is the one of the branch of electronics engineering where we have to use purposeful, the knowledge of what? Digital, say digital electronic science. Say digital electronic science. Digital electronic science. Again. Again. Okay, so ask your neighbor, do you still remember the digital electronic science you learned in A level? Ask your neighbor. When she or he reply, yes, I still remember, then ask him or her, do you still have some notes about digital electronic science? So you can borrow me to review some concept. Haha, that's not a good question, eh? Why? Because you've been looking for the marks. Okay, so these are the 4 terminologies that I want to build in your mindset. Then, I have again another key point before I take you into digital electronics. And this is the point that you have to understand. Number 5. We say that this is common, we call it a common, practical, engineering, common, practical, engineering language. In most of the fields in this world, we have something called language. Say language. Language helps people or machines to communicate, or animals to communicate. So we have also a common, say common practical engineering language. Say common practical engineering language. You say it loudly. Common practical engineering language. So if you speak practical engineering by using the following language, every engineer worldwide will understand you. So remember that the adjective, say adjective. Do you remember 8 parts of the word? Of the word. We call it 8 parts of the word. The first one, noun. Second, verb. Third, adverb. Fourth, adjective. Fifth, pronoun. Next, conjunction. Next, preposition. The other one? Pardon? Adverb. Yes, we have mentioned already adverb. So, noun. Yes, the next one is noun. Congratulations for him. Clap your hand for him. Yes, if you miss some electronics, digital electronic science concept, refer even some skills of the English language. So you don't know the 8 parts of the word, of the word. And then you don't know digital electronic science. What do you know? Football. We say that the common practical engineering language is this one. So we say that any practical engineering work may be presented by using the following 5 keywords. We say that engineering, say engineering. So engineering, regardless is mechanical engineering, electrical engineering, electronics engineering, then if it is practical, one talk practically, you have to talk by using the following 5 keywords. The first one, engineering is all about numbers. Say numbers. Say numbers. If you like engineering, you have to learn to speak in terms of numbers. And numbers, the good information about numbers, sasa shosti umefika sasa hivi, alafu kabla hata hujakaa unachukua attendance. Kwa kumbe umekuja kuandika jina Hiyo ndo bongo. That's the bongo, okay? Students used to see the attendance list even more than the place where they have to sit. So engineering is all about numbers. Say numbers. Say numbers. You are welcome. Engineering is all about the formula and the equation. Engineering is full of formula and the equation. Say formula and equation. What is mathematics? There's a different way you can define mathematics, but in every definition, you have to say that this is the study of numbers. That's why we taught you mathematics, because we want to teach you about numbers, and then you have to use those numbers to speak about engineering. Are we together? Are we together? But also in mathematics, we taught you a lot of formulas. In physics, we taught you a lot of formulas, a lot of equations. So why did we teach them? Because we need to use them in engineering field. Okay? Okay, class? Then number 3, whenever you want to speak about practical engineering, whether practical mechanical engineering, practical electronics engineering, you have to speak or to communicate your message in terms of diagrams. Say diagram loudly. Diagram. Again, say diagrams. Diagram. Say diagrams. Diagrams. In electronics, we have almost 5 main types of diagrams. We have a diagrams that we call general block diagram. We have a diagrams we call the detailed block diagram. We have a diagrams we call the schematic circuit diagram. We have a diagrams we call the PCB layout. We have a diagrams we call the flow chart that we use in computer programming. So those are the diagrams. And the goodness for you who are mechanical engineering students, you are learning about the drawing. About what? About what? Drawing. Why are you learning drawing? In order to draw different engineering systems. But unfortunately for you, you draw what you've been assigned by your teacher. So in case you don't have any assignment from the teacher, you can't draw. That's why I asked you from the beginning of this class, do you like what you are studying? Do you really like? Because if you like something, you don't need somebody to entertain you. You do it every day. For instance, do you like to eat? Ask your neighbor, do you like to eat? Do you like to eat? Then the answer is yes. Do you need somebody to entertain you to eat? Do you need somebody to entertain you to eat? It's automatic. We call it involuntary action. Isn't it? Once you are hungry, you know the solution. It's not the stories. It's not the phone call. The solution to look for what? For food. Then ask your neighbor, do you like to eat only in one semester? The other semesters you don't like to eat? Ask your neighbor. So we call it diagrams. Say again, diagrams. We can understand you as engineers if you communicate with us by diagrams more than by using words. And in case you want to explain any concept about engineering without using these 5 keywords, then we call you are a political engineer, right? Because we have a number of them. Number 4, engineering is all about what? Tables. Say tables. Say tables. And these tables, because in engineering we have to do experiments, we used to call them table of result. And we learned in science. And in the A level, you know that we were not doing the practicals. We are just using the techniques, which you call the forging. You just imagine that we don't know what you've been covering. We know. And we thank God because he's still teaching us. Then, number 5, the 5th word is called the graphs. Say graphs. Say graphs. Say graphs. Whenever you want to communicate, if you want to be a competent mechanical engineer, you have to like numbers, you have to like formulas. Stop writing. If you want to be a competent practical mechanical engineer, from today, tell your neighbor, from today, I want to like a mechanical engineering, and I would like you to talk in numbers, to talk in formula and equations, to talk by using diagrams, to talk by using mechanical tables of result, and to talk by using graphs. So my neighbor, make sure that every day or every week you ask me at least one graph. From next week, because today is Friday, from next week, ask me at least one graph of mechanical. Okay, I think your neighbor said yes, yeah. And I want to tell you that this is the philosophy we've been taught in science. Stop writing, look, let me verify how this is true. Let me verify from what you know. Right? All of us, we have gone through a level physics. All of us have gone through O-level physics, right? In O-level physics, we learned practicals at least in 3 topics. The first one, mechanical. And the common simple experiment is simple pendulum. You remember? The second one, light. And we use the glass block. The third one, electricity. And we used to implement what? Ohm's law. You remember? When we come for A-level, we learn the practicals in 3 topics. The first one is mechanical. You know that in A-level, we taught you 11 topics of mechanical science. Do you remember them? The first one, measurements. The second one, Newton's laws of motion. The third one, projectile. The fourth one, simple harmonic motion. And the fifth one, uniform circular motion. And the sixth one, rotation of the rigid body. The seventh one, fluid mechanics. The eighth one, elasticity. The ninth one, surface tension. The 10th one, kinetic theory of 40, kinetic theory of gas. The 11th, gravitational. So we taught you 11 topics of mechanical science to prepare you to come and click this stuff. Also in HIT, we taught you 3 subjects or 3 topics in HIT. We taught you about what? The first one is called what? Thermometry and thermometry. Right? Thermometers and thermometry. The second one, heat transfer. The third one, thermodynamics. And whenever you talk about mechanical, you have to talk about thermodynamics. So now we are building on top of what we have taught you. But the challenge you have, you used to forget the prior information once you pass. That's the battle I have with the students. But in case of knowledge, you know a lot. Are we together? I reminded you, isn't it? So let us come. You know, in those experiments, we have been given an experiment set and explanation, right? Then we have been asked to do the measurement and fill the table of result or prepare table of result. That's the first thing. Isn't it? You measure the periods by using the stopwatch. You use the formula to calculate the period. Right? You use the ruler to measure the length of the simple pendulum or of the pendulum. Then you will have a table of 40. Look here, students, you are chatting. Look here. So the first thing is in those physics practical, we are going to have something like this. Table of result. So from there, we taught you the applications of tables. And this is what I'm talking here. Okay? But what should we fill in these tables once we do the experiment? The physical quantity. The magnitude of the physical quantity. For instance, if this is length, this is period, then the length of pendulum, 10 centimeter. So this is length in centimeter, this is in second. What the periods? Maybe it is 12.4. These are numbers. Right? Those are not words. Those are what? We don't need weights there. We need what? Numbers. All about this one. And these numbers, you cannot find them until you do the measurements. Are we together? That is systematically. When we come for Tanzania, we find the alternative way to pass. Then, in case that so, I think that you remembered where we talked about tables of result, and then how to get numbers from that experiment. Right? 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 The next part, we ask you to draw the graph, which is 2-dimensional graph. For instance, this one, let's say the graph of period, or you say that if graph of length of pendulum against the period. Then we used it to draw those points. And then we used to draw the baseline. Then we've been asked you to find slope or gradient. You remember them? Eh? Then once we find the slope from the graph, we'll be given the formula. For instance, in case of the simple pendulum, this is the formula we often been given. Use the information from the graph. Check your neighbor. Check your neighbor. Check your neighbor. Use the information from the graph to find acceleration due to gravity. Right? Then this is what? Formula. This is what? Graph. Okay? Okay? Then once you find this one, G is equal to whatever. You make G the subject. When did we teach you how to make the subjects about the variable? We taught you in exponents and the radical, the first topic of basic mathematics form 2. So we have been preparing you to be practical mechanical engineer. But we are not sure if you still have them in your hand, in your mind, or you forgot them. Are we together? This is all about what we taught in what? In science. So in engineering, we do more than that. Because every concept we are learning in engineering, you have to do practical. And in case of electronics, we have also the power of use of computer. But for you also, you have to do the solid work. Right? For us in electronics, we have to do simulation before we go for the practical. So, engineering students, this is our language. Tell your neighbor, that is our language. This is our language. Say that. Tell your neighbor, that is our language. Are we together? Do you have any question about what you have covered up to that part? Do you have any question? You don't have a question. Why? The concept is clear. Then let me end this lecture 00 by actually answering the question, why do we teach mechanical engineering and mechatronics engineering digital electronics? Then it will be the end of my lecture. Are you ready to hear that? Why do we teach you? Why should we not teach you only mechanical engineering? Ask your neighbor, are you happy or you're not happy? So this is the last concept. Question. This will be question what? Question 6, yeah? Or question 5. Why do we teach mechanical engineering students and the mechatronics engineering students? Why do we teach digital electronics to mechanical engineering students and mechatronics engineering students? Why? So why should we teach you? Why should we not teach you about thermodynamics only? Why should we teach you about the machine elements? Why should we teach you about the engine? You're a mechanical engineer. Why do you need the knowledge of digital electronics? So because you don't like to bother yourself, ask your neighbor, why should you study this module? Ask your neighbor and listen the answer. This is your neighbor, that is your neighbor. So I have just mentioned mechanical engineering students because are the one I'm teaching them physically. And I've mentioned mechatronics engineering students because these are another related field where they have to study digital electronics. For mechatronics engineering students, it can be sounding because there's electronics in their course. But for the mechanical engineer, why these people they are teaching us digital electronics, those stuff of electronics engineering? Do I want to be electronics engineering? No, I want to be a mechanical engineer. So why these people, they actually bother my mind? That's the question you have to ask yourself. Similarly, you have to ask yourself, why do we learn thermodynamics. Where am I going to apply the knowledge of thermodynamics? Live from the moments of saying yes, yeah, yes, it is clear. Okay, sir, what are the questions are you going to ask in the exam? No, you have gone through that. You are expert. All of you have been the first students in the class. During primary and secondary, it is enough. Now be the first students on solving mechanical problem. My friend there was making a follow-up. Okay, there are so many reasons, but let me just mention 3 of them and go and make a follow-up of them. The first reason is this one. Digital electronics, say digital electronics. Say digital electronics is the heart. Let me write in capital letter. Is the heart. Is the heart of most modern automatic mechanical systems. That's the first reason. So why do we teach you the digital electronics? Because it's a heart. Say heart. Say heart. Ask your neighbor, do you have your heart? Can you show me? Then ask the second question. Do you know the main function of your heart? Can you give me your heart? You said you love me. Can you give me your heart? You can't. Why? Because once you lose your heart, you are no longer. So if you dislike digital electronics as a mechanical engineering students, then you dislike the heart of modern mechanical system. I'm talking to those students who always used to judge the modules because of the name. Digital electronics. No. We are teaching you for the particular purpose. You need this knowledge whether you like or you don't like. So we have classical mechanical system. Say classical mechanical system. Can you give me a simple classical mechanical system? Do you know trains? We call them garimoshi. You know, those are the classical trains. Nowadays, we are talking about electricity. How do you call garimoshi in English? Pardon? Locomotive trains. So do you know locomotive trains? If you want to take a locomotive train from here to Kigoma, even if you have never took it, but you hear the people, how many days are you going to spend? 3 days, like 3 days. For instance, nowadays in Tanzania we have SGR. You had the testing from Dar es Salaam to Dodoma. How long did it took? 3 hours from Dar es Salaam to Dodoma. So as the engineer, if you estimate to Kigoma, how many hours possibly? 6 hours. So, okay, take 6 hours over 3. Hey! Take 6 hours over 3 days. 3 days is equal to how many? How many hours? You don't know. 72. So, calculate. So, the locomotive spends 72. Electric train spends 6 hours. Don't you see the changes? Remember, it is still the mankind who built the locomotive train and built the electrical train. Do you see the change from 72 hours to 6 hours? So if you say, I dislike digital electronics, okay, we expect you to build the classical mechanical system, which actually will work for 72 hours, while we have the ones which have been built by digital electronics mechanical engineers, which can work for 6 hours. If we go to the shop, which one will be bought? The one of 6 hours or the one of 72 hours? So you have the answer. So it's a matter of your choice, to like it or to dislike. But when you like it, you know the advantage. When you dislike it, you know the disadvantage. Are we together? Yes. The second reason. So when we say the heart, we mean about how your heart function. So don't bother yourself. Don't bother yourself about the heart, how does it look like, and whatever. You know that we learned the heart has how many? 4 ventricles. Do you remember? Can you mention those 4 ventricles? The first one is called what? Lefty. The second one? The third one? Now, few students who can mention, because others they have forgotten. Number 2, the second reason. The second reason is that digital system, we have to learn digital electronics because digital electronics system are used to control operation of different modern mechanical systems. So you want to learn about what is controlling most of the mechanical system? That's all about digital electronics. Stop writing. For instance, one of the important mechanical system is called the elevator. Say elevator. So we have elevator in teaching tower. That is combinations of the different engineering system. But one of the system, it's electrical. Then the other ones, the structure of the car itself, of the elevator car, it's all about mechanical. Then there's electronics. Are we together? So actually the elevator, the way the elevator operates, in case that we have elevators without digital electronics, we don't have fast elevators like the one we have nowadays. That's another example of the modern mechanical system. When you say modern mechanical system, it means the main part is mechanical. Are we together? Another second example, we have cars we have automatic gear cars, and we have manual gear cars. So automatic gear cars, automatic gear cars is all about digital. And you know that to drive manual car is a challenge rather than to drive automatic. And especially for the digital age. Teenager like you. Is it clear? Is it clear? So when you say a car, the main part is mechanical. The main part is what? It consists also electronic system, it consists electrical system, it consists computer system, but the main part is mechanical. Okay? It's not like a mobile phone. In case of mobile phone, the main part is electronics and telecommunication. So that's why we call it electronics device. Hello? Hello? Then number 3, they said reasons. We said that digital, this is the last one. Tell your neighbor, that's the last one. Electronic system. So digital electronic system are used as brain. Say brain. Say brain. Mostly of what? Modern mechanical system. So if you dislike digital electronics, forget to understand the brains of most mechanical systems. Ask your neighbor, do you have brain? Ask your neighbor happily, do you have brain? Can you give me your brain? No, eh? Why? Because you cannot function without a brain. Eh? You know the importance of the brain. Similarly, if you know the importance of the brain, that's how digital electronics is the mechanical system. Class, did you understand? Yes. Is it clear? Yes. Okay. Ask any question about what you have covered. So the principle of any quality teacher, say quality teacher or gifted teacher, he may not leave his or her students without giving them a task to do. So we have homework 0, 0. Say homework 0, 0. So the homework 0, 0 it is this one. Just have simple two questions. Question number 1. Explain briefly the meaning of digital electronics circuits. This is the first question. Yes, I think that is enough. Explain what? Let us read the question. 1, 2, 3. Let us read. Explain. By, let me add the value. Using the 5 common practical what? Engineering keywords. You should not just explain by words. Explain by using what? Keywords. So explain by using graph, by using tables, by using diagram, by using formula, by using numbers. I think it is interesting work. Yeah. So just go and try your level best to make sure that you work on it. So if that's the case, do you have any question about what you've covered? No. So I would like to say this is the end of lecture 00. The end of lecture? The end of lecture 00, it's the beginning of preparations of lecture 1. I would like to take this opportunity to welcome you in lecture 1, when now we'll keep our focus, we'll do the corrections of this assignment, we'll be discussing about digital circuits. As just I've written there about digital electronics, digital electronic circuits. So actually that, what we have covered today, because of the time, we did not cover a lot about digital electronic circuits. We've covered about the digital concept. So you can change this one just to write that instead of this one, this we'll discuss next time. You can just write the title, digital what? Digital concepts. Because since I defined engineering, I was trying to look the concepts of digital. Right? So that's why I start from the big picture and then lower down until we find what? Digital electronics. Are we together? So thank you very much. May God bless you. And I'm very, very happy to have you today. But I'm always appreciating students if they understand. So before we end this class, let me congratulate you. So just see, prepare your hands to congratulate. Did you understand? Yeah. So I like students who have understood. So I would like to congratulate you because I appreciate. So 1, 2, 3. Hongera. Imara. Wow. Thank you very much. May God bless you. See you in the next lecture.